am Rasmus Benestad, and I will talk about smart data and how to make use of smart data. So this is a very simple demonstration. So I'm going to illustrate this or demonstrate this in RStudio, and R is a perfect way of working with smart data. So I'm going to make a demo object called X. That's my data object, and I'm going to give it two numbers. So give it so we say X contains two numbers, 3.5 and 5.7, and if we try to print X, we get these two numbers. So far, these numbers could be anything, or they could be fairly meaningless. So we want to put them into context, and we want to provide some additional information, and we can do that with attributes. So if you say that the variable here is temperature, for instance, and we also need to give it some units as well. So then we say, okay, it's degrees centigrade, for instance. So if we now plot print X, then we get these attributes as well. But we don't know where these date temperatures are from. So if we say location, and we say these are two different locations, let's say Oslo and Copenhagen. So now we have and also maybe we say these are measurements for certain dates. So you can say like that, 2020, 1st of March, for instance. So now if we print the information, then we have both the numbers and also what variable it is, and also unit and location and date. One way to also show this some of this information, see what kind of object we are working with, is to use the command called str, that's for structure X, and here you see it's a more sort of abbreviated form. So it says it's a numeric object with some numbers, and it has 4 different attributes. We can also write names here as well, and like that. And you see these are just attributes, and then we can say, okay, the attributes are just like tags. They don't get in the way when we do the operation. So say if we say z, let's say y is 273.15. We don't give it any attributes now, but if we call z equals x plus y, you see that z inherits the attributes of x, but now we say it's actually in Kelvin, so we can say units degree Kelvin, and then if you look at z, we change the no, sorry, we had to change z. So now we have degrees Kelvin instead. So we make use of this principle in our tools when we analyze climate data. We have made this R package, a tool available on GitHub called ESD. That's Extreme Simple Data, and with ESD we can get some station data, and it's from a thread server. So we say source equals metno d for daily dot threads, and then IT, that's index time. We say we want to only get data from 2000 to 2020, so we don't get all of it. And now it will actually read the data from OpenDAP, and it's stored as a netcdf file. If I read all of it, there are some problems with the system, so it doesn't read all the data properly. I don't know what's the reason for that. So now we can say, okay, names attribute y. So now we have the big Y here, right? So the case matters. So if I had written with small y, I would get nothing. So this, the big Y is where we have all the data, when small y doesn't exist. And we can also do a str big Y, and you can see it has a lot of attributes. So the functions in ESD take care of all these attributes and do all the housekeeping when it comes to all the metadata. And the nice thing here is that with Y we can say, okay, loc Y, that's a location, so it picks a location that tells you where, like the names of the places where the measurements are done. Long Y, that gives you the longitudes of the coordinates where the measurement is done, and then also lat Y, that's all the latitudes coordinates, or you can do alt, that's for altitude. So then you can see how high above the sea level the measurements are made, and this makes life easier. It makes it much quicker to work with the data because you have very simple ways of extracting this information. And this information is also used when we make, say, map the data. So we map Y, and we say function equals mean. So then we want to show the mean values of the station data, and you can see we have one station, one measurement down on Antarctica, and that makes the map look really strange. So we want to remove that, and we can do that because we have all this smart data and all the information about their location. So we say subset Y. So we just say we copy it into itself, but now with a subset, and is index space equals, and I have to use a list in the environment here to indicate that I want to have several things I want to use when I dissect the data. So we say longitude equals between 0 and 40, and then we say latitude equals 50 and 75. So now I want to dissect, I want to only extract the places which are between 0 and 40 east and between 50 and 75 north. So if I do that, you can see that now we have a smaller subset. If I write dim Y, you can see that that's the size of the data. Map, and then if I repeat map Y mean, you see now I get a map of all the stations and also the temperatures here. This is the mean temperature from Norway, and so that's, and if you look at stry, you see that it's between 2000 and 2020, so that's 20 years of data. So it's a very, very quick way of working with data when you have smart data, and adding information about. So here we have unit variable, as you recognize, longitude, latitude, altitude, but also country. So you can filter on country. We added an attribute called long name to explain that this is a mean temperature, so it's a daily mean temperature, and also the station ID numbers, because the different stations have ID numbers, and quality, which we haven't added here, what kind of calendar we use, and also source, which we should actually add some more information here, and also the URL where it's downloaded from, and also info. So here you can add more information, and also there's a history attribute here, and if you look at that, you'll see that it has a list of 3. So it gives you what kind of R version I used, and what kind of ESD version, and what kind of platform. but also here it would give the commands that were used in order to get this data, to make it more transparent and provide provenance, and also provide time steps of when I actually did this analysis as well. So this is just like a simple way of working with smart data in R, and I hope that will make life much easier when you want to do the analysis, and also make your analysis more transparent, so that you can reproduce the data, so it's more reproducible and also quicker to work with.